Section 2.3 is applications of equations, and we're going to be solving application problems in this section. A lot of review of Algebra 1 and Algebra 2 stuff, and just in some applications. So we're going to work through 8 problems here in this section to get you started. So the first one, you have the description. It's the average of two real numbers is 39.625. One of the numbers is 1500 times the reciprocal of the other, and we want to find the two numbers. All right, so the first thing we want to do is to set up an equation. So first of all, it's talking about the average of two numbers. So we know to average two numbers, we're going to add them up and divide by 2. So the first number, let's say that is x, and then the second number is going to be 1500 times the reciprocal. Okay, so that means 1500 times the reciprocal. Okay, so this would be the reciprocal of this guy, okay, here. So now we have that. All right, and it says the average is equal to 39.625. Okay, so now we have that equation set up. We're just going to go ahead and try to solve it. One thing you notice is that you have an x in the denominator, and we're going to try to simplify this because on the left-hand side we sort of have a fraction within a fraction, and it's getting kind of complicated. So first thing I'm going to do is multiply both sides by 2, or just multiply the entire equation by 2. And when I do that, that eliminates the denominator of 2 on the left-hand side, leaving me with 15. Leaving me with this. Okay, so still we have an issue here because we have an x in our denominator, and I would like to get rid of that. Now, from the information we're given in the word problem, we know, and since we have an x in the denominator, x is not going to be equal to 0. So I'm going to now multiply both sides by x. And when I multiply both sides by x, I will get x times x is x squared, plus when I multiply x times the 1500 over x, the x's cancel out, and I'm left with the 1500. Equal to, and then the 79.25 times x. And I get this. All right, as you can tell now, it's looking like a quadratic, and I probably am not going to be able to factor this since I have the 79.25x. So it's looking like a calculator problem at this point, and that should be a minus. And if you think back to the last section, you know that in this case, we could have used the intersection method, or here we're going to use the x-intercept method now that I have everything on one side of the equation. What's going to be the difficult part is going to be finding a good window. So I already have this equation in. Make sure you're trying this out. Right now would be a good time to go ahead and plug this into your calculator and see if you can come up with a solution and find the window yourself. But I have my, let's see, do I have this equation in? I don't have this equation in. Okay, actually, you know, instead of doing this one on our calculator, I think what I'll do is I'll use the quadratic formula, but you can certainly use your calculator to do it. Let's just try this one a different way. Let's just do a quick review. I forgot that I wanted to do a quick review of the quadratic formula. So quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So in this case here, what we have is that a is going to be 1, it's the coefficient of your quadratic term. B is going to be the negative 79.25. And C is going to be 1500. So given all of that information, we can say, all right, then x is going to be 79.25 plus or minus square root 79.25 squared minus 4 times 1 times 1500. So that is all divided by 2 times 1. Okay, so first you go through and you say 79 plus 79.25 plus the square root divided by the 2, and then you do minus the square root there. It will give you two answers. The first one is 48, and the second one would be 31.25. So those are your two solutions there. That would be the first one. So we're trying to find the two numbers. So the first one would be 48. And if we have 48 as x, then x, or 1500 over x, and in this case would be, and then we could simplify that. So we could have this set, these being the two numbers, and then in this case over here, you've got the 1500 over x would be the second number. So if it's 31.25, and we just need to simplify those. So it would be, these two would be your two solutions. Okay, so that's it for that problem. Again, you could have done this with your calculator, but I wanted to do a review of the quadratic formula because you should be able to use this with quadratics. Okay, here we have the width of a rectangle is 3 times its height, and it has an area of 60.75 square feet, and what we're looking for is the dimensions of the rectangle. All right, so I would start out by setting up your variables, and you can really do that with a diagram in this case. So we've got the height here, and then it says that the width is 3 times the height, so we're going to come up with this. And this one is pretty easy to set up. You know that the area of a rectangle is going to be length times width, so we can just do this. And we know the area of that rectangle is 60.75, so we get this. So that's 3h squared is equal to 60.75. And then I would divide both sides by 3, and that would simplify to h squared is equal to the 20.25. And then once you have that, you can take the square root of both sides. And when you take the square root of both sides, you're going to end up with h is equal to plus or minus, positive or negative. Anytime you take the square root, you have to say the positive and the negative, 4.5. Now, we know in this case, since h is height, then the only thing that we're going to get is that h is equal to positive 4.5. It could not be negative in this case. So if h is 4.5, then 3 times h, or your width here, is going to be 13.5. So that means that the dimensions are going to be 4.5 feet by 13.5 feet. And this would be the answer. And don't forget to go back and read your question and make sure that you are answering the question with these word problems that's saying what are the dimensions, and we have given the dimensions in this case. All right, in part 3, or in number 3, we have a storage locker in the shape of a rectangular prism with a square floor, has a volume of 70,000 cubic inches. The surface area of the 4 walls and the top is 10,000 square inches. And what are the dimensions of the locker? Okay, so for this one right here, we're going to have to set up two equations. All right, so first of all, it tells us that the volume is 70,000 cubic inches. So since it has a square base, if you think about it has a square base, this is the base. Then that's x, then that's x, okay? And then the height, we could say, is equal to y. All right, if that's the case, then one of the equations we can set up here is that the volume is going to be length times width times height. So in that case, it's x squared times y is equal to 70,000. And then now that we have that equation set up, we need to move on and think about setting up the other equation, which deals with the surface area here. So we know that the 4 walls and the top is going to be 10,000 square inches. So if that's the case, then what we need to say is, okay, the base of this is going to be x squared. That's the area of the base. In addition to that, we have 4 sides. Now, if you think about this diagram here, each one of the sides is going to have that x base, but it's going to have a height of y. So the area of any of the sides is just going to be x times y. And if you think about a Kleenex box, how many sides does it have around it? It's going to have four sides around it. So that x squared, which is the area of one of the bases because it doesn't have a top, plus 4 of the xy's is going to be equal to 10,000 square feet. So now we have the two equations set up, and we need to work through this as a system of equations here to solve this problem. So starting with this first equation here, we'll call this the second equation. With the first equation, we can solve for y pretty easily and then substitute that into the second equation. So if I solve for y, then I get y is equal to 70,000. And we know it's okay to divide by that x squared because x is not going to be negative since it's going to be a dimension of this rectangular prism. So 70,000 divided by x squared. Once I have that, I can take this and substitute it in for y in this equation. And that leaves me with x squared plus 4x times the quantity 70,000 over x squared is equal to 10,000. All right, so from here I simplify this. The x's will cancel out in that second term, so x squared plus 4 times the 70,000 is going to give me 28,000 over just a single x because one of them cancel out is equal to 10,000. Okay, and now that I am at this step here, I need to think about, like I did in one of the previous problems, how to eliminate that x in the denominator. That sort of throws things off. So what I'm going to do is like I did last time, knowing x is not going to be 0, I'm going to multiply through by x. And when I do, that's going to give me x cubed plus 28,000 is equal to 10,000x. Now, at this point, I have a cubic. I'm not going to be able to use a quadratic formula, so I'm going to get everything on one side and then look for the zeros. So that leaves me with x cubed minus the 10,000x plus 28,000 equals 0. Now, at this point, it would be a good time for you to stop, graph this in your calculator, and see if you can come up with a good viewing window to find the solutions for this. I already know what the viewing window is, so it's going to be good for you to play around. One thing you might want to think about is the numbers are going to be really big. If you think about what your y-intercept might be, you know your y-intercept would be when that's 0 and that's 0. So basically, your y-intercept ends up being 280,000. So that tells you need a pretty big scale. So here on my calculator, I already have my equation in. If I go to graph, I'm not sure what kind of graph I have here, but it's probably, yeah, we're going to see a little something. So I'm going to go to my window, and I am going to change my x minimum to -10, my x max to 100, that's good. My scale at 10, that means I'm going to have a hash mark every 10 instead of every 1. And then my y, my minimum, I'm going to make it -100,000. And I'm going to make my y max 300,000. And I'm going to make this okay, and let's see the graph here now. Okay, and now we see enough to see what's going on. We don't see the full shape of the graph, but we see enough to notice that we have a couple of positive x-intercepts, which is what we want. We want positive values for x because these are dimensions of a rectangle. So what I'm going to do now is find those x-intercepts. So I'm going to do second calc. I go down to number 2, which is my 0. I'm looking for a left boundary. So I'm going to find this one on the left first. So I'm finding a left boundary. Just press enter. And now I'm looking for a right boundary. Press enter, and yes, I'd like it to guess. And so that gives me one solution is where x is approximately 30.97. So, okay, so that's one possibility. And let's go back and find the other one. Second calc again. I'm looking for number 2, which is a 0. Getting a little close to that second 0. Okay, pretty close. So press enter, go to the other side, to the right side of it. Press enter, and yes, we'd like it to guess. And so it looks like the second one is at approximately 80.85. Okay, so again, we're looking for what are the dimensions of the locker. So if that's 80.85, then you should be able to plug that into one of the two equations and find out what the y value is. And probably the easiest one is going to be the first equation. So you've got x squared times y is equal to the 70,000. So if you plug each of those in here, and then you found two separate ones. So we've got the x. We might want to use this version of it. And see if you can come up with the two possibilities there. All right, so first I have 30.97 by 72.98. And then here you would want to make sure you label this, and this should be in inches, okay? So this is inches, this is inches. Okay, so that's one possibility. And then the other possibility is going to be the 80.85 inches by 10.71 inches. Okay, so these are two answers in this case. All right, we have a fourth problem. It's just a simple interest problem. So before we do this problem, let's just review simple interest. Interest is equal to principal times your rate times your time. So P is your principal and R is your rate. So in this case, it's 10% and then possibly 6%, and then your time in this case, which is a year. So you've got a real estate investment that yields a return of 10% per year and a certificate of deposit or CD that pays 6% interest per year. How much of the $7,500 should be put into the real estate investment and how much into the CD to obtain a return of 7% on the entire $7,500? Okay, so you've got two amounts that are going to be invested here. That's the key. So let's say that that you invest X dollars at the 10%. Okay, so this is going to money. Okay, if X dollars is invested at 10%, then there's only a total of $7,500. So the amount invested at the other rate, which is 6%, is going to be 7,500 minus the X. So okay, so we have that. Those are the two amounts. Now what we want to happen is we would like a total of 7% on the entire $7,500 to be the result. So we know that to figure out that amount, what we do is use the simple interest, which is principal, which would be the 7,500, times the rate, which is 7%, so we change that to a decimal, times the time, which is 1 year. That's what we want. and we want these other two investments to add up to that. So how do we get to that? Well, what we have to do is we want to use, again, principal times rate times time. So the first one's going to be invested at 10%, which is 0.1, times the principal times the time, which is 1. So that's 0.1 times x, which is the amount invested at 10%, plus the principal on the second amount, which is 7,500 minus x, times the rate, which is 0.006, times the 1 year. Okay, so we have that equation set up, and from here it's just simplifying. So we've got 0.1x, and then we have plus 450 minus 0.06x is going to be equal to the 525. And then we just continue simplifying this. You've got the 0.1x minus the 0.06x, which is going to leave us with 0.04x plus the 450 equals 525. Continue with your algebra. Okay, so the amount invested, if you look at your x is going to be the amount invested at the 10% interest rate. So what we know is that this is going to be $1,875. Okay, and then if that's the case, then 7,500 minus the x tells us the amount that's invested at 6%, which is going to be $5,625. Okay, and so those, and of course you need to tell that this belongs here and this here to get the answer correct. Okay, so that's part 1. These are the first 4 problems. I will do another recording for the second 4.